Good afternoon, everybody. Welcome back to a Workflow Wednesday. My name is Phil Brown. I'm with JitCAD Cam. I do have to apologize this video going out on a Thursday. That's my fault for accidentally recording and setting the publish date wrong. So as you guys can see in my background, this week we're actually going to cover what we did down at Red Dirt USA. They went ahead and upgraded from a Tormach machine to a Haas with a 4th axis, and they moved from a part that was a 4 to 5 setup process into a 2 setup process that actually allows them to dramatically increase not only capacity, but dramatically reduce that cycle time as well. And I'm going to show you guys how most companies would go from a prototype of an idea into mass production and how you could scale up or scale down based on your needs and wants. So let's go ahead and jump into this and see what this is going to take. So I already have my part file here. Obviously, I haven't done anything based on the CAM side of things. Me personally, I like to spend a little bit of time here because I need to think in the world that it's one thing to do, let's say, 5 parts where I'm going to load each part individually. It's another to start thinking about doing maybe a set of 50 where I'm loading a bar of 5. And then it's a whole nother if you're having the problem like they were having where they needed to backlog about 3,000 of just one model, right? So usually I keep that in mind because efficiency is key. And this is where I can play around with stuff without wasting a ton of time, is in that first operation. So now we all don't have a 4th axis. We may be thinking of a 4th axis. I'm going to program this part off the start as if maybe it was a 3-axis or a 4-axis type of scenario. So let's go ahead and start with our setup. As you can see, we have our XYZ set up. That's more than okay. I would actually have my stock size fixed size box. I can't speak this morning. It's been a while since I've made these videos, as you guys can see. And then we're going to go ahead and go off the top. And I like to keep it right around like 20 to 30 if you guys have ever seen any of my other videos. So now with that concept of possibly doing this with a 4th, I do want to make sure maybe I'm clearing some serrated jaws if I'm using a 5th axis vise of that nature, or maybe this is just the material I had laying around on the shelf, right, guys? Usually you want to keep your material small due to cost. However, sometimes more material makes easy manufacturing, and it's amazing what a 2-inch face mill will do. So as always, we're going to go ahead and we're going to face off this part. So I'm going to go into my default library, as you guys know so well, and I'm just going to pull the good old standard 2-inch face mill. A lot of things with Fusion, as you guys know, stock selection, it is predictive. It's already looking at what it does and doesn't need to do. And as you can see, we've faced off that part. The next thing I'm going to do is I'm probably going to do a 2D adaptive clearing. We're just going to run this right around the outside of this part. And in the case of when we were doing this on their machine, a lot of people would probably think we're crazy, but we did a lot of this based on a 1/4-inch flat end mill. Yes, we could have gone to a 1/2 inch. However, what we noticed when going to the 1/4 inch is we saved more time in a tool change, and the actual cycle time was almost minimally different. Again, this allowed us to get a lot more parts a lot closer based on what we're doing. As you can see, we now roughed around the outside of this part. I'm going to go ahead and hit this with a drive. And again, we're going to go in and hit a 2D contour. And just like that, we've kind of done the outside of this part. Now, if you guys aren't familiar with these basic tool paths, go check out a few of my other videos. I did a Milling Monday segment where we walk through the absolute basics. I don't want to bore you guys to death with this. I wanted to get you the idea that we've applied a few tool paths here. You know, we're going to come in, we're going to do some 4th axis work. But let's scale this up now, right? So I'm comfortable with this. You know what? Let's say, you know, maybe we did a 2nd setup for the 4th and a 3rd setup for the backside, right? Well, let's scale this up. Let's run, you know, maybe a couple out of a bar. This is the first thing I think a lot of people miss inside of Fusion 360 is I'm going to take a step back because I did just accidentally mention we're not going to run them out of a bar yet. Let's say we're going to run them in multiple vices, right? So this is the first way to achieve the same repetitive task across multiple vices. Now, let's say we had 4 vices. Well, again, if I needed to very small scale up so that I get a longer cycle time and reduce tool change amount of time, is what I'm going to do is I'm going to go in and I'm going to set multiple work offsets, and then I'm going to set the number of instances. So WCS offset 1 is going to be my 54, and then we're going to use the next 4 offsets to include the first one, and we're going up by 1. So that's 54, 55, 56, 57. So this is honestly probably one of the easiest ways to get away with duplicating, across vices. So that's what I like to say is we created multiple work offsets across multiple actual vices. So now that works again to scale up just a little bit. If you're like me, maybe you don't have 4 vices, maybe we only have 2 vices. Again, you can walk through the process of Fusion 360 and you can instead go back down to 2 vices, things of that nature. Now, me personally, I'm not going to run, say, 200 of these parts across 4 vices based on that system, right? And the reason why I'm not going to do that is hand loading each individual 200 blocks or making technically 200 saw cuts to set up 200 blocks of material is kind of a pain in the ass, right? So the next progression is if we move out of prototyping, and what I like to do is I like to say the next step is kind of small scale production, right? Where we're going to start thinking in the world of loading a bar of material into that machine, and that way we could actually produce multiple parts. So what I'm going to do is I'm going to switch back to the design side of Fusion 360, and I am actually going to use the pattern toolpath. So as you can see, I'm going to use rectangular pattern. Now, this is where I think a lot of people miss this important step, and you guys are going to see why, right? So any of us could take the body, and we could click our body, we could set our direction, and we could create an even increment of spacing, whatever that is, based on our parts and our profile. Now, this is where the terminology in Fusion is extremely important, right? So as you can see right here is we pattern the body. The bad news is I need to remember quantity and distance if I was to go back to manufacturing for patterning. And you'll see that here in a minute. Now, the proper way to achieve this task, in my opinion, is to actually pattern the component, right? So my component is what we're looking to pattern. But as you guys can see here, the way we set up this process is I can't actually pick that part. And the reason why that is because I actually opened the part file, and that is my main component inside of this actual file, and I don't have the ability to go in and pick it. Now, what that's going to require me to do is to go ahead and kick open a new design, and this is where we really start to get into the concept of production. So what I'm going to do is I'm going to save this, and this one is actually going to be labeled, I'm just going to call it the STC3, and this is going to be production. And this is a great workflow for a lot of you guys to get into. And what I'm going to do is I'm going to start out by creating a brand new component. And the reason for that is this is going to be my parts folder or organization, right? So with that activated, we're going to go ahead and kick open that data panel. I'm going to go ahead and bring in that first trigger. As you can see, it went ahead and snapped into position in the same way. And if we look at our organization, we are now linked externally, right? So again, kind of thinking along that line of maybe we're still early prototyping. Once you get something into production, you may realize if we change this, change that. The idea of linking this to an external file allows me, no matter what we do, I can update that original file, which we have open here, and those changes automatically push through to Fusion, and we'll do that a little bit here in a second. But now what I'm going to do is, again, we're going to repeat kind of what we tried to do before. We're going to do our pattern. We're going to say component. And now notice is I can select the component. And that's because this component is technically in a subassembly inside of a main assembly. Again, I like to do that parts kind of component for organization purposes more than anything. But now we pick our direction. Again, we could set our spacing, whatever that may be. So I'm going to go ahead and leave that at 270. Again, we're trying to get this down so that it is an easy process. That is our goal, and that is our game plan right now. So as you can see, I have my 3 triggers now. We're going to run these out of a bar. I'm going to go ahead and jump back to manufacture. Notice how, again, because we originally programmed the part versus programming the assembly, that's why our tool paths are missing. Here's a pro tip for you guys if you didn't know. We could actually go in and we could highlight that entire original setup, and we could go in and we could paste that inside of Fusion, bringing over everything. However, we will have to reselect some stuff. So this is where we need to define our models for manufacturing. And this is why I tend to put all that stuff in what I call a parts component. because if I had 1,000 triggers in here for some reason, I'm not picking them 1,000 times. I'm going to my parts component and grabbing them all in one shot. Again, my stock size is fully customizable and updated. So as you can see, a lot of that information came through because it's recognizing a box around those parts. And then we could start the regeneration process of what we're doing. So now we're facing all three. I'm going to go into my 2D adaptive. And in this case, we're going to go ahead and unselect. And I'm going to go through and pick each individual component. And as you can see, we're roughing around everything. And again, this is where we can go for a closed chain. So as most of you are noticing, we're starting to be a little redundant with something. And that is selecting each part. So if there was 10 parts, am I going to have to select 10 times for each toolpath? And the answer is no. That's the best thing about this. So take, for example, this 2D contour. And this is where we really start to speed up our programming while also increasing our production on the shop floor, right? So one thing I am going to do is I am actually only going to select one of these. And the reason for that is because if we go up to the setup area, we can create a new pattern. Now, this is a toolpath pattern, not a part model pattern as we did before. But one thing you're going to notice is this works very much the same. So I did warn you guys about the idea of patterning a body. Well, if you did pattern a body, you did need to know your quantity, your distance of spacing, and that information you would have to manually plug in here. Now, there's some other options, and I think I might do a video on this because I was on site with another company that does wheels. That being said, as a circular pattern, when you're doing with spokes, is again, I don't need to program the whole part. I need to program one slice of the pie and create multiple slices of that pie. Now, mirror pattern, if you're doing something like a mold cavity that's ambidextrous, again, very handy. Duplicate pattern, for you guys out there that did bodies, duplicate pattern works pretty good because as you can see, I could manually select the same point across my part, but I'm still manually selecting stuff. That's no fun, right? Like, I don't want to go pick 25 pieces every time I want to do something like this. So what I'm going to do is I'm actually going to use component pattern. Again, pointing back to the reason why you should start a second file as all of your manufacturing and link your component back, allowing those be individualized parts inside of an assembly, right? So again, we're going to go into our source, and now notice automatically it's going to go through and grab each additional one for me. I could manually do this. The nice thing with component pattern, and this is something that nobody ever realizes, is when we start to get into that world of running 2 bars of material, we can actually do these profiles on any component in kind of any configuration or orientation. So again, we went ahead and we actually went through and we cut those profiles. I could activate that pattern at any time. One thing I might want to do is split in between these guys. Let's do, again, a 2D contour. Thankfully for Fusion's amazing new chaining, I actually have the ability to get away with quite a bit here. But let's just say we're going to go a 1/2 inch start, 1/2 inch end. Again, this is a splitting tool path, so we don't want to be right on top of that part. So we're going to go ahead and bump it away, 30. We're going to keep our depth the same. And then lastly, I don't need lead in, lead out. There's no wear here to split apart that profile. But as you can see, again, the idea is just to break these apart, right? Now, based on our pattern, what you're going to notice, and this is, again, the great thing you have going on, is it's patterning that the same each and every time. Now, it gets better than that, right? So we did this based off maybe sticking it in a, 4-inch jaw vise, right? But we have a 6-inch jaw vise, or we have 8-inch stepped soft jaws. Now, when we really start to think about that scaling up, is we kind of did a proof of concept, right, for prototyping. We did a proof of concept now for defining a larger amount of parts being able to load into the machine. And we have that ability in Fusion to change our pattern at any time and increase what we're doing. So this time I'm actually going to set everything to spacing. And I think we're going to go, 1.3, maybe 1.25. Again, because we're patterning components, when we go back to manufacture, everything is pretty self-recognized right off the start, right? So again, as if we go through and regenerate our couple of tool paths, as you can see, it's patterned it all the way down. Now, I know I'm going to get this question, And I'm going to show you guys is we don't want to split the very end, right? We only want to go in between the parts. I'm going to duplicate my pattern using Control D, or you could right click and go to duplicate. And this is where I would pull one toolpath out of one side and then the other toolpath out of the other side. So if we start to get into the technicalities here, I'm now going to face my part off, then I'm going to split it. And this is where I could actually say is instead of an automatic pattern, maybe I'm going to do a manually selected pattern, leaving my last part out, right? So again, we're now splitting that apart. My 2D contour, no offense to anybody out there, as you can see, because of the manual selection process, it didn't update, and we're actually going to scrap some parts here. I'm going to switch from a 2D contour to a 3D contour. Now, if you know why I'm going 3D contour, I want you guys to go ahead and put that down in the chat, because a lot of people always go 2D, and I strongly disagree with that unless what you're doing is a very simple square part, or as you saw, it worked very quick for a single part. So what we're going to do is we're going to keep that 1/4 inch end mill. We're going to go ahead and leave on rest machining. Again, if we wanted to change our step over or our step down, we could do so. But I'm going to go ahead and hit OK. And what you're going to notice is this ended up in my pattern folder because that was active. And we don't necessarily want that. So I'm going to go ahead and drag it down so that I get it out of that folder. But what's going to happen here is it's going to recognize anywhere that there is no machined material already, right? So the idea of the patterning of splitting this and then going into rest machining is going to actually be very beneficial for what we're doing. Now, keep in mind here, because of stock to leave and other constraints on this toolpath, we're not actually going all the way around our part, right? And we could change that. So we could change our spacing. We could actually say our minimum cutting radius is different. Maybe our actual stock to leave is 10. Again, I'm going to play with this real quick and see if we can't get it down nice and clean. As you can see, we're now splitting in between those parts, making very large archy kind of toolpaths when we don't need to. So we could go back once again. We have that ability to do quite a bit of adjusting based on what we need to get that refined. Now, again, the whole idea of using 3D, as you can see, I didn't physically pick anything on my part. So now let's scale this up even more, right? So this is where, when we go back to design, we've ran now a little bigger bar, right? Like I like to say is we're maximizing the vise, right? And now because that's a bar, we could actually put them in, take them out in a bar quantity. So 1 bar of 5 parts, allowing us to load into our jigs and fixtures easier if we did, we machined our soft jaws to mimic the same pattern. Now, I'm going to show you guys a little tip here when we start to talk about getting into really high production. Now, in my opinion, if I go down to my parameters, I actually have the ability to control these patterns based on several different equations. Now, this is the big part. Again, we could do a lot of guessing here. And in the case of Red Dirt, these guys make, probably 40 different makes and models of triggers. So if you guys are looking for a trigger, go check them out and buy some and tell them that I sent you. But that being said, is sometimes you need to change the spacing, or in their case, we built an equation that always does the exact same spacing, right? So for example, you may know the distance from end of bar. So I like to say distance from end. And what we're going to do is we're going to set that to like 3/4 of an inch. So another thing we could do is we could set our spacing, right? And what this expression is going to be is it actually could be distance from end times 2, right? So I like to always compare this to the idea if you've ever framed a wall before, you have that first stud and then every additional stud after that. We could even go in and we could say number of parts. So in this case, this is actually going to be a no units. And again, this is kind of key here. So we're going to say, let's say we're going to try to squeeze 12 parts in there. But now that we've started to plug this information in, we have the ability to do quite a bit here. So for example is we're going to plug in number of parts. And then another thing, what I'm going to do is I'm going to come down here is we have our distance for spacing, right? And as you can see, in real time, my Fusion 360 is updating on those parameters. Now, we're going to get a little more technical here, and you're going to see where we could do a few more things that are going to be extremely beneficial for what we're doing. So as you can see, we did our first row of parts. We may do a second row of parts. I'm actually going to create what's called another component. And this is where I like to put in my stock, right? So based on using a physical stock body, again, is going to make my life easier inside of Fusion. So we're going to go ahead and call this stock A. And then we're going to do nothing more than create a box. And we're going to look down from the top here. So again, as I'm very generically drawing this box, because as you can imagine, we're going to edit this pretty good at the end of the day. So again, we go back to our change parameters. As you can see here, we're going to go ahead and open up our stock that we just created. And now we do have, like our width, our height, maybe it's 1 inch wide. Our length could be determined on, for example, number of parts. And then we're going to take that times our actual distance from, or our spacing, right? So what you're going to see is we can update based on those parameters. Now we should be able to equally get that in. Again, if you wanted a different spacing from the end of the part to center on both ends, you could have did, number of parts -1. Like we could get really, really technical here if we had to, right? And then this is the thickness of my material. And if I remember correctly, we might have went 3/4. No, we did go 1/2 inch because we also used Mighty Bytes when doing this. So as you can see, I now have my bar, I have my parts. This is where if I wanted to, we could do some joint configuration. And it's what I would recommend when you're starting to set this all up. So what I'm going to do is we're going to go ahead and do a joint from here. And then I like to go based off center of that top face. So as you can see, if I put my mouse on that face and hold control, I get this nice little lovely rectangle. We're actually upside down. We're going to go ahead and drop that Z by 20. Oh, we need to go 20 positive because I'm thinking backwards. And then again, is based on shifting it to the left, this is my distance from end. And again, this needs to be a negative, so we could plug in a negative in front of it. And what I was going for, as you can see, is encasing all of those parts. And we could change the opacity here so we could see this a little better. But the idea is that I want to go in and actually get this set up. Oh, let's go ahead and activate our main assembly. Is that these parts are placed inside the bar with more or less precision and being able to maintain something consistent for what we're going to do, right? So again, as you can see, we did quite a lot, and I did that very quick. And if you guys ever have questions about this, feel free to reach out to me. But again, it's by modeling my stock and using parameters, I am controlling all variables here, right? And the cool thing is if you ever go back to your change parameters, is as you're going to see here is I can actually see the length of my bar is 18. We have 12 parts. And if we even wanted to make this even easier on somebody, we could actually say, stock L, right? And stock L can be based off an equation also. So again, is I know that is going to be D9, right? So again, as we could go in and we could say that's actually D9. And then it shows up here at the top. So you don't have to be in here rooting around for things. So if we go to, let's say 14 parts, as you notice, my stock is now automatically updated to 21. Again, squeezing in all those parts as much as possible. This is the true value of now getting into that world of mass production, right? From here, we could do quite a bit, like I said before. So as you can see, is we have one entire bar with everything in it. I'm actually going to do a rigid group. And the idea of a rigid group is the ability to actually now take the rest of my parts and group them all together and get them locked. So if I grab this and move it, I'm going to get the obviously capture position move. Let's get my origin back on. You guys have a point of reference. But my bar and all of my parts are now moving automatically. Let's revert that back. But what that also allows me to do is to take possibly all of those parts and my stock. And again, as we could do a copy and paste, Control-C, Control-V. And I'm going to spin this, preferably not upside down, but we're going to spin it 180 degrees. And we're going to now generically get this over here. And again, as I could do a rigid group for everything and anything. So let's go ahead and say rigid group. And if you're kind of wondering, is what we're doing right now is we are manually kind of prepping everything for what we're going to do after the fact, right? So in this case, I actually need to put this bar not on that side, but we're going to go ahead and pull this here and here. And if I was using Mighty Bytes, I would have those Mighty Bytes all set up in here. But again, rigid group to trigger to the bar. I can move the bar. Everything stays the same. And what we're mainly looking at, right, is that we're in the same plane, whether that is going to work or not, right? So now let's go back to manufacture one more time. So a lot of you are probably like, holy cow, this is getting all over the place. However, I've offloaded all of my actual work for prepping these triggers and getting everything set to my actual design side of things. Because when we go into Fusion and start talking about our patterns, right? So again, here's my first go around for that first part. Now, notice, because that component pattern, it's picking up everything automatically. So no longer does it matter how many parts I do, because my toolpaths are redundant and repetitive, and they're finding my parts automatically and going through that process, right? So in my setup, I just need to go through and define all my parts, of course, as you saw me do that before. And because the way I did my copy and paste, this is going to be a little dirty. And the reason for that is because everything is no longer in one area. So it is going to be spaced out based on, you can see these are all individualized at the wrong component level. So I made that mistake, but you can organize a little better on your end. But let's go ahead and grab all of these as well. And so you guys know I'm just using Shift and Control in combination to pick individual items. For those of you on a Mac, I believe you can do the same, but it's the Command key. But there's all of my parts. Oh, let's go ahead and go back one more time. And we're going to change our stock to a solid, right? So the reason why we're going to go with a solid stock is because this is going to allow us to go in and define our two bars individually and utilize that in our parameters of our toolpath, right? So if we go into our face mill, what you notice is it's thinking the outer perimeter of both stocks. Again, we could go through and we could manually set this. So let's get our stock turned on real quick. And now what I'm going to do is I'm going to select each individual one. And now you can see that although it does run down and back and forth, is if I adjust my tool, it would make one stripe on one stripe on the other. Again, if the spacing changes, my parts are realigned in any different way, you're going to see a pretty dramatic difference in change. Again, we have that splitting toolpath. So we had that first part, we had the few extras. Again, this is a very simple thing for me to add a few more clicks to do this. But as you can see, is we can actually generate that splitting now all the way down the part. One trick I did do here is made a mistake, of course, we'll fix that. But again, with only having to do one row because of the way everything is aligned, I may actually go in and set my extension to include 3 inches, which is probably overkill. But as you can see, I can split both bars at the same time now, right? So I don't need 2 separate sets of toolpaths, and this is where we're using component pattern to pick and choose our process. Let's go in and fix that real quick. I don't want that last part because it's kind of pointless to go ahead and machine the end of the part. And then from there, we have our roughing, of course, so we can go ahead and regenerate our roughing. That is going to go around again and find anywhere and everywhere that it needs to machine based on a difference between our stock and... If you haven't guessed it yet, put it down in the comment because I'm not going to say it here. But now you're starting to see where we're not slotting with our adaptive clearing, but we are now making that space in between. Again, we gave this a much bigger space based on those part files. So again, we don't have to like do a ton of arcs to kill our cycle time. We're splitting these apart with that flat M mill, and then we're going in and we're roughing out each individual one. Again, this patterning is your best friend, in my opinion. I don't use anything except circle pattern, and I use circle pattern only when I need round objects, of course. But the actual ability to go in and use component pattern, as you can see, has taken this entire part, and we went from let's run 1 in one vise to running 1 in multiple vices, then running a small bar in one vise, which you could do a combination. You could do a small bar in multiple vices, again, using that quantity that we use. Let's say we do 3 in this vise, and then we do 4 vices, we get 12 parts per cycle. So all the way scaled up to what I assume, if I'm remembering correctly, it's 14 times 2. We're now doing 28 pieces out of 2 bars, right? We're not doing 12 pieces out of 4 bars. Again, reducing the number of saw cuts, making it easier to load and unload. So with that, guys, I am going to let you go, and let me know what you think of this video. Go ahead and like, comment, subscribe. If you want to stay up to date, don't forget to turn on notifications as I publish these videos, even when they're published a day late like today. That being said, it's not what you know, it's who you know. Know myself, Phil Brown, over here at JetCAD Cam, and any Fusion problems you have, post-processor edits you need, or even training to get you up to date and get you schooled up to be able to accomplish tasks like this, feel free to reach out to me with the link down below.